This week we have 3 questions from Chapter 1. Questions 1. Figure 1 shows a polystyrene ball coated with a metallic coating, has a mass of 4 grams and carries a charge Q. It is suspended by a thread in a uniform electric field of 6,400 Newton per Coulomb. When the system is in equilibrium, the thread is inclined at 15 degrees with the vertical. Find the charge Q. When it comes to a vector questions, it is always a good idea to start from a diagram. So step 1, sketch free body diagram. Now let us look at the original diagram. So this is a diagram given. We have a polystyrene ball and now you place it inside an electric field. So what are we going to do right now? Well, obviously the object is the polystyrene ball, so we start from the object. It's a dot. And then if you look at the diagram, this polystyrene ball is being hung by a thread. Therefore, it comes with a tensions. So you have a tensions that is 15 degrees from the vertical. Now, don't forget about the angle, because this value is given in the original diagram. Therefore, you need to include it in your free body diagram. Next, well, now you place it inside an electric field and it is being attracted to the right-hand side, which shows that there is an electric force pointing to the right-hand side. And at last, if you look at these questions again, now you have a polystyrene ball with mass. So it means there's a weight pointing downwards. So that is a complete free body diagram for this question. And then what are we going to do? Step 2. Form equations. Well, you have 3 vectors pointing towards different direction, and they are all not lying on the same component. Therefore, we are going to resolve them into x and y component. So if you look at x component, now based on the free body diagram, obviously Fe is lying on the x component. And then vector t, this tension is lying in between x and y. So you need to resolve it. After you resolve it, you will get t cos 15 degree lying on the y component and t sine 50 degree lying on the x component. So now let's see how are we going to form the equations. So for x component, we have t sine 15 degree equals to Fe. Why t sine 15 degree equals to Fe? Because after you resolve t, tx is lying on the x component and it is pointing to the left. Fe is pointing to the right. Both of them, they are pointing towards opposite directions, and this system is now in equilibrium. Therefore, the values is equal. And then if you expand the equations, you will get t sine 15 degree equals to Q naught E. And that would be our equations number 1. Now let's look at y component. Y component, the equations we have is t cos 15 degree equals to W. Why t cos 15 degree equals to W? Once again, if you resolve tensions, ty is heading upwards and W is pointing downward. Since the system is in equilibrium, therefore upwards vector is equals to the downwards vector. So t cos 15 degree is equals to W. If you expand these equations, you will get t cos 15 degree equals to mg. And that would be our second equations. Now that we have an equation from x component and an equation from y component, let us solve the question. Step 3, solve the equations. The easiest way to solve the equation is to use equations 1 divided by equations 2. So we will have t sine 15 degree divided by t cos 15 degree equals to Q naught E divided by mg. T and t, you can cancel it out. And when you use sine theta divided by cos theta, you will then obtain a tangent theta. So now we have tangent 15 degree equals to Q naught E over mg. Let's substitute the values into the equations. We will then get the 15 degree equals to, now I replace Q naught with capital letter Q because this is the symbol used in our questions. So Q times 6,400 Newton per Coulomb divided by 4 times 10 to the power of negative 3 times 9.81. So this 9.81 is a constant value where you can get it from the list of constant. Solve the equations and you will get Q equals to 1.64 times 10 to the power of negative 6 Coulomb. But that is not the end of the questions. Why? Because you still don't know whether this charge is a positive charge or a negative charge. If you remember, in chapter 1, when we use F equals to Q naught E, we always modulus the Q naught. Thus, we can tell whether this Q naught is a positive or a negative value. So what are we going to do to determine the sign conventions of the charge? Let us go back to the original diagram. So when you have a diagram like this, where the electric field is moving from right hand side to the left hand side, okay, so we can always assume there are two plates on both sides. So now let us determine the sign conventions of the plate. So if you have two plates on both sides, the invisible plate on the right hand side is a positive plate because we know that electric field is coming out from positive and it's going to enter negative. Therefore, the plate on the left hand side is a negative plate. So now let's look at the diagram. Since this ball is being attracted to the right hand side, so which shows that this ball is a negative charge. How do I know it is negative? Well, because there is an attractive force between this polystyrene ball and the positive plate. Therefore, this polystyrene ball, it should be a negative charge. Now, other than that, you can also determine it by using the method. So Q is a negative charge because the vector F and E, they are in the opposite direction. So we can also conclude that Q is a negative charge, and therefore we are going to write it as Q equals to negative 1.64 times 10 to the power of negative 6 Coulomb. Questions 2. Figure 2 shows the cross-sections of equal potential surface at various distance x from a point O in an electric field. If an electron moves from the equal potential surface 55 volt towards 50 volt, determines the change in kinetic energy of the electron. State whether the kinetic energy is an increment or a decrement. We know that K is equals to half mv squared. But in these questions, you are not given any information about the velocity of the electron. So how are we going to solve the question? Let us look at the diagram. In this diagram, the information that we have is the electron is moving from the 55 volt potential line towards the 50 volt potential line. There is a change in the potential, which indicates that there is a change in potential energy as well. So can we use the change in potential energy to solve the question? Well, yes. Because summations E is equal to K plus U and it is equal to a constant value. The change in potential energy is equal to the change in kinetic energy. So now let us determine the change in potential energy. Change in potential energy delta U is equal to Q naught delta V. Expand the equations. We have delta U equals to E times V final minus V initial. Now, if you look at this equation, I substitute E as a negative value because electron is a negative charge. So negative 1.6 times 10 to the power of negative 19 times V final is 50, V initial is 55. So 50 minus 55, which give you negative 5. And you will then obtain delta U equals to 8 times 10 to the power of negative 19 joule. It is a positive value, which shows that there's an increment in the potential energy. So then how are we going to tell what happens to the kinetic energy? Since summations E is equals to K plus U is equals to a constant value, therefore we know that increase in potential energy will be equals to the decrease in the kinetic energy. Therefore, the kinetic energy of the electron is decreased by 8 times 10 to the power of negative 19 joule. Questions 3. Figure 3 shows an electron entering uniform electric field with a horizontal speed of 1.2 times 10 to the power of 7 meter per second. The two parallel charge plates, which are 4 cm apart, have a potential difference of 300 volt. The length of each plate is 6 cm. Calculate the actual velocity of the electron when it emerged from the electric field. If you look at the path traveled by the electron, you will notice that the situations given is horizontal projectile motions. When it comes to horizontal projectile motions, the initial velocity u is equals to ux and it is equals to vx, which shows us that the velocity is always constant along the x component. Whereas for y component, uy is equals to 0, but then vy is not equals to 0, which means there is a accelerations along the vertical component. Now, let us go back to the x component. Since we say velocity is constant along the x component, therefore for x component, ax is equals to 0 ms negative 2. Applies the equations Sx equals to uxt, substitutes the values into the equations and you will obtain times is equals to 5 times 10 to the power of negative 9 seconds. This is the time needed for the electron to travel through the plate. Now, why do we need this time? Because we're going to use it to calculate the velocity along the vertical component. Just now we mentioned that when it comes to horizontal projectile motions, uy is equals to 0, but then vy is not equals to 0, which indicate that there's an acceleration along the y component. So let us apply Newton's second law for y component. Summations Fy is equals to may. Now, if you look at the questions again, we know that the force that causes the electron to accelerate is the electric force. Therefore, these equations can also be written as Fe equals to may. And expand the equations again, since Fe is equals to Q naught E, so now we have Q naught E equals to may. But then we don't have the information about the electric field as well. So what are we going to do? Now let us substitute E equals to delta V over D. So we have Q naught times delta V over D equals to may as our equations now. And since we have electron in the questions, so we can replace Q naught as E, and M, we are going to use a mass for electron. So rewrite the equations as E times delta V over D equals to ME times AY. Now that we have the equations that we want to use, let us substitute the values into the equations. So substitute everything into the equation, and you will obtain AY equals to 1.32 times 10 to the power of 15 meter per second squared. Now that we have the accelerations along the y component and the time needed to travel through the plate, we can then apply the equations Vy equals to Ayt to calculate the velocity along the y component. So substitute the values into the equations and you will obtain Vy equals to 6.6 times 10 to the power of 6 meter per second. Now, sometimes students will ask me, since you are given the distance between two plates, why can't you calculate Vy by using V squared equals to 2as? Now, that is because Sy it does not equals to the distance between two plates. If you wish to use the equations V squared equals to 2ay, then you must calculate Sy first, which is much harder compared to calculate the time taken to travel through the plate by using the x component. Alright, so let's look at the V. This V is not the final answer yet. That is not the velocity of the electron when it emerged from the plate. If you look at the questions, it just mentioned velocity without telling you whether the velocity belongs to x or y component, which means what the questions want is actually the resultant velocity. Therefore, the velocity of the electron should be calculated by using V equals to square root Vx squared plus Vy squared. Substitute the values into the equations and you will get the velocity of the electron equals to 1.37 times 10 to the power of 7 meter per second. Since velocity is a vector, so don't forget about the directions. So directions can be determined by using tangent theta equals to Vy over Vx. Rearrange the equations and substitute the values of velocity into the equations. You will then obtain theta equals to 28.8 degrees. Now, don't forget to describe the positions of this angle. So by looking at the values of a Vx and Vy, since both of them they are positive, which indicate that this angle is located in the first quadrant. Therefore, we can say it is located above positive x-axis. So that's all for week 14. I will see you all again tomorrow.